Okay, a pleasant afternoon to everyone. Welcome to my physics class. I hope you are all in a good mood today for learning, and I hope you're going to enjoy the new things that you can learn this afternoon. Okay, so now to start with, for this afternoon session, you are expected or be guided with these learning objectives. So, to start with, for today, we are going to derive equations of motion for an object with constant acceleration. And then we're going to solve related problems using the equations of motion. So now let's have a review first. We all know that mechanics is the study of relationships among force, matter, and motion. And of course, under mechanics, if you could still remember, we have the kinematics, we also have the dynamics. So when we say kinematics, what does it mean? What does it mean by kinematics? It deals with the description of motion. So that means when we say kinematics, it is the study of motion without reference to the forces that cause that motion. Meaning to say, it does not explore the cause of the motion. It will just only describe the motion. On the other hand, when we say dynamics, it explains how an object moves in terms of the forces which change its motion. So, the dynamics means the motion of a body under the influence of forces. So meaning to say, it is the study also of how forces affect motion. So it will explain how, or it will explore the cause of motion. Unlike in kinematics, it does not explore the cause of motion. But in dynamics, it will explain or explore the cause of the motion. So that is the difference between kinematics and dynamics. Okay, now let's go to equations of motions. So in the equations of motion class, we have things to consider. Okay? So as you can see, there are quantities that we can consider or we are very concerned of in the equations of motion. Here are the quantities. We have the S, as you can see. We have S for displacement. We also have your U for initial velocity. And we also have V as your final velocity. And you have A, acceleration, and T for time. In short, these quantities that you can see on the screen, these are the concerned quantities that we can use or that we will encounter in the equations of motion. So now, let's try to derive the equations of motion. Let's start with deriving the first equation. The first equation will something to do, or is something to do rather, with the velocity, time, and acceleration. So as you can see, class, the graph, or in the graph, we can see that what? What have you observed in the graph? It is something related to velocity and time. So that will give you an acceleration. So as a review, velocity is meter per second and time is measured by second. So now, let's try to observe the equation for a while. Okay. So we have here the U that will serve as your initial velocity. And then the graph or the line is a straight line. Then here, then you have it there. You have the vertical and horizontal line. So after that, we can say that the initial velocity has 0 time. That is why the coordinate, or the coordinates rather, for your velocity based on this graph, for the initial velocity rather, based on this graph is 0u, where 0 represents as your time. Again, initial velocity will start at 0 in here based on the graph, and then you have it 0u as its coordinates. And after that, we can have, or we can just stop in this line in here at this point where we have the coordinates of your final velocity, which is your v. So now, as you can see, time changes. That's why we have, since velocity changes, so the coordinate for the final velocity affected by the time is t and v. So now, the graph shows the relationships between velocity and time. So based on this graph, or in this illustration, we can now say, since it is a straight line or equation of the line, as you can see in the graph, we can also connect it, since we have the vertical and horizontal line, as you can see in the broken line, we can say that there is a gradient, or the slope of the line based on the illustration. We can let y, the vertical line, we can just have it as your y, and then your horizontal line can be your what? Can be your horizontal line. That's why your gradient or your slope in this line can be equal to the change of y over change of x. As you can see for the gradient, there is a change of your y over the change of your x. So we can just have it, or simply say, okay, v minus u all over t minus 0. Where did we get v minus u? This is just subtracting or finding the difference of your final velocity minus the initial velocity. Remember this formula, the v minus u. V, the final velocity minus the initial velocity. In mathematics, we derive it from the equation of the line y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Wherein your y sub 2 is your final velocity, and then your y sub 1 is the initial velocity. Then after that, since we have the change of x, to compute the change of your x, all we have to do is just get the difference of the final time over the initial time. So as you can see, your x sub 2, your final time is t minus the initial time, which is taken from the time of the initial velocity, which is 0. That's why we have t minus 0. So that's how we got it. Then next, to simplify or to solve it, we can just say that, or we can have it as a, or the average velocity, is equal to, or average acceleration rather, the a, average acceleration, is equal to v minus u all over time. So now we can now derive the equation 1 by just simplifying. Okay, so we have it, a times t, cross multiply, a times t is 80 is equal to v minus u. So after that, you can transpose it here, the u. So that becomes u plus 80 equals v. So now, we can have the final equation based on how we derive the velocity and time and acceleration, or the equation 1 can now describe as v is equal to u plus at. Final velocity is equal to the initial velocity plus acceleration times the time. So this is now our equation 1. So this is our equation 1 class. So this is how we derive it. So next, after deriving the equation 1, we can now we can apply it in this given problem. So in question 1, we can say that the rocket shown in figure 2.12, as you can see in the picture on the screen, off from the rest with an acceleration of 20 meter per second squared. So calculate its velocity after 50 seconds. So how do we calculate its velocity after 50 seconds? So the first thing that we are going to do in solving this problem is we have to identify, of course, the given, and after that, the what is being asked. So to find what we know, we have to analyze the situation or the problem. So what we know now is we have the initial velocity of 0 meter per second since it lifts up from rest. So it starts from 0 based also on the graph that I've shown a while ago. So we have the initial 0 meter per second. And another thing also for the acceleration, we have 20 meter per second squared based on the given. And also for the, since we are looking for the final velocity, then the given for your time is 50 seconds. So these are what we know. Next is we should know what we should also consider what we want to know. And what we want to know based on the given problem is finding the final velocity. So V is question mark. So now to solve the equation, we will follow the formula, the equation 1 that we just derived a while ago. We have V is equal to U plus AT. Then after that, we can substitute. So to substitute, just replace the given to the variables in the equation that we have, in equation 1 rather. Then by calculating 20 times 50, that gives you what? 1,000 meter per second. Meaning to say this is our final velocity. So this is our final velocity. So that's how we apply, the equation 1. Now next, we will now proceed to deriving the equation 2. So equation 2 is something to do or related with displacement, velocity, and time. So as a recall or recap, so average velocity is equal to the total distance, displacement rather, over total time. And after that, okay, so average velocity can be denoted in that symbol. And also for the total displacement, remember the quantities, it is represented by S over total time, which is T. So we can have this formula for our average velocity. So as a recall, then we are going to solve to derive the equation 2. We will first solve for S. So to solve for S, of course, we have to cross multiply. That gives us S is equal to V times T. So next is we're going to solve what is an average velocity. What is average velocity? So now, if you could still remember, average velocity is equal to the initial velocity plus the final velocity divided by 2. It's just getting the average velocity. Yeah, that's why we call it average velocity. So we all know that V, the average velocity, is U plus V all over 2. So we will just, next, we will just substitute it to the equation, this one. Then substitute the value of your V in here. And that gives you in this equation 2. So equation 2 will just give us the idea about the displacement, wherein there is also a velocity and time relationship. So this is equation 2 for the equation of motion. So now we will try to derive another equation related to displacement, which is equation 3. So equation 3 is displacement, time, and acceleration. Compared to equation 2, it's like time and velocity, displacement, time, and velocity. In equation 3 will be related to the displacement, time, and acceleration. So to start with, of course, we have to review that from equation 1, we can have V is equal to U plus AT. And also, we also, from the equation 2, we review that the average velocity is U plus V all over 2. So we can name it as equation A. Then after that, we will substitute equation 1 to equation A, which is V equals U plus V all over 2. So now we will substitute again equation 1 to equation A. That's why your V here becomes, or shall I say your V here becomes U plus AT. Okay? So by just substituting your equation 1 to equation A, then your V now becomes U plus AT, which can be solved or simplify. So to simplify, we can have it U plus U equals to U, combining like terms, plus 80. So now we can have V equals, your average velocity now is equal to U plus 1/2 AT. So how did we get it? We can just, this one, we can just have it 2U over 2 plus 80 over 2. So we can just cancel it out. That's why we have U, then plus 80 over 2, or can be written as 1/2 AT. Okay? So now, we are not yet done. Again, we are trying to derive equation 3, which is the equation for displacement. So after that, after we got that, we got this, the one that I encircled. V is equal to U plus 1/2 AT. But we all know that the average velocity can be also written as displacement, total displacement over the total time, which is S over T. Correct? Could you still remember? So we can now substitute this one in here, in this equation. So we can have ST is equal to U plus 1/2 AT. And after that, we will solve. Okay? To solve, we can have it, we can cross multiply the T. So after we cross multiply the T, then you have it, S is equal to UT plus 1/2 AT squared. So how did we cross multiply it? By multiplying both sides of the equation by T. So cancel T here, that's why S will be left, which is your displacement, is equal to T times U is UT. Then T times 1/2 AT becomes 1/2 AT squared. So this is your equation 3 in the equation of motion. But you have also to consider class about this one. When your initial velocity is 0, of course, you have to consider the formula now will change into S is equal to 1/2 AT squared once the initial velocity is 0. Okay? So I hope you can follow. So now we can now proceed to the next. But let's try to apply this one first. So let's try to apply equation 3 in this given problem. A train in figure 2.14, I'll move first my pic so you can see. Okay, so traveling at 20 meter per second accelerates at 0.50 meter per second squared for 30 seconds. Calculate the distance traveled by the train in this time. So how? How do we solve it? Of course, as what I said, in solving problem solving, we have to identify the problem and identify the given. So what we know here are the initial velocity is 20 meter per second, while the time here is 30 seconds, and then it accelerates at 0.50 meter per second squared. So I want you to try it on your seats if you want. So what we want to know is, of course, calculate the distance traveled by the train in this time. So we are going to look, what we want to know is we're going to solve for the distance or displacement or the S. Okay, so now the equation that we can use it can be based in the equation that we just derived a while ago, the equation 3. So one thing also, class, to use for clue in solving problems here in kinematics, you have to consider the given. What will be the given, or your formula to be used are based or is based on the given that you have. Okay? So we can use the equation 3 where we have S is equal to UT plus 1/2 AT squared. So next, we will substitute the given that we have, we substitute it to the equation. So we can now have it 20 for your initial, and then for your time 30 seconds plus 1/2 times 0.5, which is your A, and 30 again is your times 30 squared based on the formula. Then after we substitute, then we can solve or simplify rather, or calculate. So 20 times 30 is 600. 1/2 times 1/2 times 0.5 times 30 squared becomes 225, and then when you add it, that gives you 825 meter. So this is our distance traveled by the train in this time. Okay, so I hope everybody got it correct or got the correct answer. So now, after the equation 3, of course, we have 4 equations in kinematics, or basic equations. So the next equation will tell us the displacement, velocity, and acceleration relationships. So how do we describe, or how do we derive the equation number 4 based on the displacement, velocity, and acceleration quantities? So let's recall that equation 2 is S is equal to U plus V all over 2 times T. And then if we try to solve for your T, then you have a T equals 2S over U plus V. Where did we get it? We cross multiply. 2 times S is 2S. Then you have it U plus V times time. Then divide both sides by U plus V. Yeah, you have here U plus V. Then cancel it out. Then your T is equal to 2S over U plus V. So this is the result for solving for your T. So next, We can denote your t as your equation A. Then you use equation 1. V is equal to u plus at. Then substitute equation A to equation 1. So substitute your time in here. So to substitute, we can now have it like V equals U plus A times the quantity of 2S over U plus V. Then simplify and solve for your V. So to solve it, you can have it, you can solve for your V as V is equal to U plus A times the quantity of 2S over U plus B. Then multiply both sides of the equation by the LCD U plus V. So U plus V times V becomes now V times U plus V. So as you can see there. And then U plus V, multiply it by U, that gives you U times U plus V. Distribute U plus V in here. You can cancel it out. And what will remain is A times 2S, which is 2AS. And what's next? We can continue simplifying to solve for your V. So to solve for your V, then we will simplify, multiply. We will multiply or distribute or remove the parentheses by distributing by distributive property. V times U is UV. V times V is V squared. Then U times U is U squared. Then U times V is UV. Then plus AS. After that, we can perhaps arrange or arrange the formula to solve for your V. So to arrange it, of course, when you try to, this one, UV will be canceled because that becomes UV minus UV. And then V squared is now U squared plus 2AS. And this is your equation 4. Okay? Again, we eliminate this one because that becomes UV minus UV. That is equal to 0. So what will remain now is V squared equals U squared plus 2AS. And that describes our equation 4. Okay, so I hope you can follow. So now, let's try to apply our equation 4 class. So to apply your equation 4, let's have to apply it in this given example. So in question 3, we have the cyclist in figure 2.15 is traveling at 15 meters per second. She brakes so that she doesn't collide with the wall. Calculate the magnitude of her deceleration. So what we know in here, we have the initial velocity, which is 15 meters per second, and your final velocity, which is 0 meter per second, and also your displacement, which is, 18 meters. Okay? So based on the given, okay, look at the illustration. Your U is 15 meter per second, check. Your final velocity is 0, check. And then your displacement is 18 meters. So now we will try to identify what we want to know. What we want to know is the acceleration. We will calculate, but this time it's the deceleration. So expect that you will have a negative acceleration. So we'll use the equation V squared equals U squared plus 2AS. Then we substitute, or first rearrange first rather. So to rearrange this one, since we're looking for your acceleration, this one, so we have to move it there. So that gives you V squared minus U squared equals 2AS. Then divide both sides by 2S by 2S because we are looking for your A or acceleration. So then cancel this one. Then that gives you, by rearranging, that gives you A equals v squared minus u squared all over 2s to find your deceleration. Next is, of course, we have to substitute. Your v is 0. That's why we have 0 squared. Your u is 15 meter. So 15 meter per second. 15 squared rather. So we have it, your 2 times s, your s is 18 meters. So we can calculate now, after substituting, we can calculate negative 225 over 36. So calculation then gives us acceleration, which is negative 6.25 meter per second squared. And that is our final, answer. Your acceleration is, yeah, it decelerates at negative 6.25 meter per second squared. So I hope everybody got it. So just recall. So the equations of motion, equation 1, we have v equals u plus at. Equation 2 is s is equal to u plus v all over t, u plus v over 2 times t. And then we have it s, for your equation 3, you have s is equal to ut plus 1/2 at squared. And for your equation 4, you have v squared equals u squared plus 2as. So these are the 4 equations of motion that we just derived. So remember the quantities where s is the displacement, u is the initial velocity, v is the final velocity, a is the acceleration, and t is for your time taken. Always remember that these equations can only be used for motion in a straight line, for an object with constant acceleration. So please remember, you can only use this one for a motion with in a straight line and for an object with constant acceleration. So I hope you got it. Do not forget that one. Now this time, I'll give you time to do your activity. So you can do now your activity.